Okay, uh, today's topic is determination of coefficient of consolidation. How we can calculate the coefficient of consolidation value from our laboratory test. Actually, already we have discussed the all the parameters, all the coefficients which are actually. Sir, आपका voice नहीं आ रहा sir. Oh, sorry. Okay. Actually, oh, sorry. Uh, today, today we are discussing, or today we will discuss the determination of coefficient of consolidation. Okay, so already we have discussed the all the coefficients which are already involved in our uh, mm, our this consolidation part. Normally this coefficient of consolidation, how can we calculate from the laboratory test? How can we find out the value from the our laboratory experiment? This is our today's topic. Just wait. So today already we know what is the coefficient of consolidation and another other parameters which are in your consolidation chapter. In coefficient of consolidation, or to find out the coefficient of consolidation from laboratory test, we have two methods. First one is square root of time fitting method. These methods are actually used in your laboratory to find out the coefficient of consolidation value. हाँ सर आपका आवाज नहीं आ रहा सर. अरे यार. अच्छा रुको. एक एक सुनो सुनो. सर आपको कोई म्यूट कर दिया सर. प्रॉब्लम. हाँ wait. Actually I have allowed one person. I have actually I have allowed one person from outside. That was the matter. Yes. One person, only one person I have allowed, and already he left the meeting. Okay, no problem. Fake account था सर, बाहर से मत allow. Actually, with photo. Actually, he is enter with photo. Okay, so there is two methods. One is square root of time fitting method, and another is logarithm of time fitting method to find out the consolidation value. Okay, coefficient of consolidation. So suppose for the uh, एक 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 आदमी को सिर्फ एंटर किया था. तुम लोग जस्ट एक रुको, एक काम कर सकते हो, ऑल ऑफ यू जस्ट लीव करो, एक बार लीव करो फिर एंटर करो. ठीक है, एक बार लीव कर जाओ फिर एंटर कर दो. सब लीव हो जाओ, फिर एंटर करो, फिर सब लीव हो जाओ. आ गए सर. अच्छा 2 मिनट रुक जाओ। हाँ, इसको बाहर कर देते पहले। 2 मिनट रुक जाओ, ये एंटर करेगा। 2 मिनट बाद एंटर कर रहा है। एक्चुअली ये जो स्टूडेंट एंटर किया था वो क्लास नहीं करता, एक्चुअली उसको देख के मैंने एंटर किया उसको। 2 मिनट रुक जाओ, ये एंटर।
सर वो उसका अकाउंट नहीं था सर, उसका अकाउंट दूसरा है।
हाँ, मुझे पता है उसका ना। एक्चुअली हम लोगों का बहुत सारा प्रॉब्लम है, क्योंकि बहुत लोग क्लास नहीं करते, उन लोगों को अलाउ करना पड़ता है बाहर से। तो वो नाम देख के और उसका वो फोटो देख के अलाउ किया था, तो वो ही गलत हो गया। अभी तो पता चला ऐसा।
सर ये सब जो स्टूडेंट सब जो कर रहा है ना सर,
हाँ हाँ
उसी के बारे में कर रहा है जो आता नहीं है।
हाँ, वो तो पता है।
नॉर्मली के बारे में करेगा ना तो सर पकड़ा जाएगा फिर।
हाँ, मुझे पता है। आउटसाइड में एक जन ही किया है, एक जन को ही किया गया है। जस्ट हाँ, वो तो सभी रिकॉर्डिंग हो रहा है ना, वो तो सब रिकॉर्ड हो रहा है। कर सकते हैं एक्चुअली।
उसका जीमेल देख सकते हैं, जीमेल।
हाँ हाँ हाँ, जीमेल उसका अभी अभी एक्चुअली अभी नहीं दिखा सकते। क्लास जब ये होगा, खत्म होगा, उसके बाद दिखा सकते। तो 2 मिनट रुक जाओ, ठीक है। 2 मिनट रुक जाओ, इसको एकदम बाहर करेंगे। एंटर करने दो एक बार, सिर्फ एंटर करना पड़ेगा उसको। एंटर नहीं करने से वो बीच बीच में एंटर कर रहा है। जब भी पढ़ा रहा हूँ स्टार्टिंग में वो कर रहा है। और नहीं तो एक काम करना पड़ेगा। जस्ट मैं और एक लिंक बना रहा हूँ, ठीक है। जस्ट वेट, एक लिंक बना रहा हूँ, उसमें से तुम लोग एंटर कर सकते हो।
ज्वाइन किया सर, फिर छोड़ तो चला भी गया।
रुको रुको, लेट होने दो थोड़ा, कुछ प्रॉब्लम नहीं है, नहीं, क्योंकि बीच बीच में आएगा। 1 मिनट रुक जाओ, 1 मिनट रुक जाओ।
वो आएगा तो बोलना मत, वरना चला जाएगा।
रुक जाओ, हो जाएगा, थोड़ा रुक जाओ, कुछ प्रॉब्लम नहीं।
वो हम लोग वो आ रहा है माला करके बीच में केवल।
हाँ हाँ हाँ, पता है, सब कुछ पता है। हम लोग भी स्टूडेंट थे, तो हम लोग तो टीचर एक दिन में नहीं बने।
तो आप लोग ऑनलाइन क्लास नहीं ना किए होंगे?
हाँ, ऑनलाइन क्लास नहीं किए हैं, तो ऑनलाइन क्लास तो ले रहे हैं अभी। पता है, सब कुछ ही पता है, सब कुछ है, सब कुछ। उसके लिए बहुत पेलना पड़ता है, ठीक है। उसके बाद आना पड़ता है इस जगह में। रुको, मैं दे रहा हूँ तुम लोगों को लिंक, उसको बना के दे रहा हूँ। ऐसा टेंशन मतलब, हो जाएगा सब कुछ, सब कुछ हो जाएगा। इमोशनली सब कुछ होता है तो ठीक है, होगा, सब कुछ होगा, टेंशन नहीं। 9 टाइम देते हैं तुम्हारा 9:15, ठीक है। 9:15 वाला टाइम देते हैं। 9:15 ज्वाइन विद गूगल मीट। ओके, सब ठीक है। सेव, ओके, ओके, लैपटॉप ओके, सेंड। देखो तुम लोगों को एक जस्ट मैंने सेंड किया है एक मेल में सबको। देखो, इसको लिप करो, लिप करके उससे एंटर करो, ठीक है। जस्ट मैंने सेंड किया है। ठीक है। हाँ, ये दूसरा लिंक से आया तो।
यस सर।
ओके ओके, ठीक है, थैंक यू। अच्छा, so there are two methods to find out the coefficient of consolidation. One is square root of time fitting method, and another is logarithm of time fitting method. Okay, so square root of time fitting method. Just first, if we discuss about the square root of time fitting method, we can calculate using any one of the method to find out the coefficient of consolidation in our laboratory. So when our concern is the square root of time fitting method, suppose the factors which are involved to find out these particular value square root of time fitting coefficient of consolidation, then using this square root of time fitting method, we need already, which we have discussed earlier, the two values, that is the time factor and degree of consolidation. Time factor and degree of consolidation. So this is the actual formula of time factor, which is already discussed in previous classes. I think one and two class before, I think. So this is the one time factor, this t, and another parameter which is need to find out the coefficient of consolidation in laboratory using square root of time fitting method, that is degree of consolidation. So one is that is u value, degree of consolidation, which is need to find out the coefficient of consolidation, and another value, that is another factor, that is time or time factor, to find out the coefficient of consolidation. So these two these two values are required, u and t, or this formula is required to find out. If we go our actual slide, this is the relation, theoretical curve between root over TV and u. TV is the actually time factor, u is the degree of consolidation. Okay, so in this figure, a theoretical characteristics curve between root over TV, that is time factor, and u, the degree of consolidation, has shown. The curve is straight. As you can see, the curve is straight up to u equals to 60%. Okay, u equals to 60%, and the abscissa at u equals to 90%. 90% is equal to 1.15 times the abscissa at u equals to 60%. Generally, normally देखो, if degree of compression or degree of consolidation, same thing, 60% and 90%, and this curve is coming first coming from 0. This curve value initially starting from 0, degree of consolidation or degree of compression starting from 0, then it is coming at 60 value, and further it is going depending upon your time factor, it is going the in the direction where the time factor is increasing. So at 60 value and 90 value, this is our important values. That's why here the a value, the magnitude of time factor, it is 0.80. First, you can see in the figure, the a value is taken, the a value is 0.80, which is taken, and b value, which is 0.92. From where this is coming, the curve is straight up to u equals to 60%. As we know, the degree of consolidation is represented by percentage, so the curve is straight up to u equals to 60%, and the abscissa at u equals to 90% is equal to 1.15 times the abscissa at u equals to 60%. So this deviation value, okay, or the b by a value is 1.15 times. B by a equals to 1.15 times. So at 60 your value is suppose a, the straight line. At 60 to 90 the a value is 0.80 straight line, but actual deviated value b value is the actual curve value. This is the tangent, we can say one tangent. This is the actual your compression with time factor, actual your degree of compression or degree of consolidation, this b value. But if we draw a tangent or straight line, this is a value, okay. And this deviation part, this extended deviated part, we can calculate by this b value by a value, that is 1.15 times. Therefore, from this curve, it is clear that U60 is one of the important, U90 one is the important. So another part is if U60 is the one value, U90 is the another value. Both values are important to find out your the theoretical curve or your relation, to find out the root of time factor, relation between time factor and degree of consolidation or compression. Actually this curve, the aim to show this curve is actually the use of these characteristics of the theoretical curve to determine the 90% degree of consolidation point on a laboratory time consolidation curve was suggested by Taylor. So actually the reason behind of this curve is, you will get after some time. The method consists of drawing the curve between root of time as abscissa and the dial reading are representing the compression of specimen as ordinate for any pressure increment in consolidation test. Suppose you have seen this curve, after that I am showing you one table, okay. The table which is used to determination of coefficient of consolidation by this method, this square root of time fitting method. This for this under the square root of time fitting method, you can see this table, or you need this table to find out the all the values, okay. And just before this table you have seen this curve, this theoretical curve. Now suppose what's have written in table. First we need pressure range. Suppose in your laboratory test there is pressure, there are lots of pressure. So here the pressure range, suppose 100 kilonewton meter square to 200 kilonewton meter square, or 100 kPa to 200 kPa. Initial height of specimen under pressure of 100 kilonewton per meter square is 17.38 mm, and final height of specimen of, that means your soil specimen, is 16.11. okay. So first pressure is which is counted, that is 100, and second pressure is 200, and first initial reading is 17.38 mm and final height of specimen is 16.11 mm, okay. So elapsed time already we had some idea elapsed time in consolidation, because to perform test we need the elapsed time, series of time, to find out our actual consolidation or settlement of the specimen. So elapsed time already we had the series of elapsed time. Suppose this is the value of some 0.25, 1, 2.25, 4, 6.25, 9, 12.25, 16, 20.25, 25, 36, 49, 60 minutes. These are the values of elapsed time. Same values, suppose we have taken, or and these values are maintained in our laboratory test. So also you can see same values in this table to determine the coefficient of consolidation. 0, 0.25, then 1, 2.25, 4, 6.25, 9, 12.25, 16, 20.25. And another column you can see, that is root over t, because elapsed time, if elapsed time is t, we need actual root over t. Okay, actual we need root over t to find out our coefficient of consolidation. And dial reading is also we will get from our laboratory test, because our specimen is settling or due to load, so there will be some readings how much my specimen is decreasing its height, and from this dial gauge reading we can calculate actual our specimen, the settlement of our specimen, and these are the dial reading values. So to find out the determination of coefficient of consolidation by square root of time fitting method, we need this table, this elapsed time, dial reading, root over t, and the fundamental of this theoretical curve. Okay, that is the relation between degree of compression or degree of consolidation and time factor. So if we go to the final equation through which we can calculate our CV value, then you can see the, suppose initial dial reading, R0, the initial dial reading R0. Okay. You can see from this graph that this is the graph which is drawn from this value, this t value, root over t value, and dial reading value. So in this graph you can see at abscissa square root of time is given, and in the ordinate part dial readings are mentioned. So y-axis is dial reading and x-axis is square root of time, which is the values which are available from this table, and we have to collect the dial reading from our laboratory test. We have to, and we know the elapsed time, because at this elapsed time we are getting these dial reading values. So after available of these values, we can draw this graph. At x-axis is of square root of time and y-axis is dial reading. So this, from this graph you can see the initial dial reading R0, our value is starting from R0 corresponding to the time t0. So where our R0 at corresponding to time at t0, when t is equals to 0, r equals to 0. When time is 0, starting initial time is 0, our dial reading is 0, R0, and also u is 0, degree of consolidation also 0, u equals to 0. The straight portion line, that is line A. Okay, suppose this is actual our compression line. Okay, over the time, this is the actual our compression time. This solid line is our actual compression line over the time, or this is the dial reading over the time, which we have got from our laboratory test. Now the straight portion line, that is line A. Line A, one is the tangent of this our actual compression line, this compression curve, this line A, dotted line, one tangent, okay, has drawn straight line, that is straight line. This line is produced back to meet the ordinate at reading RC. So this tangent line we have extended at tail portion and the starting portion we extended to find out the actual corrected reading, because initially due to void soil behaves like different, because soil is not linear, soil behaves like non-linear. So due to this non-linear behavior we have to calculate our correct reading. How we can calculate? Only using this straight tangent line we can calculate the correct reading of our consolidation of the sample. Suppose actual consolidation curve, you can see this curve is not straight. Due to nonlinear behavior of soil, this curve is producing some curve, some irregular values. We are getting some irregular values which is not producing a balanced result, or it is very difficult to find out this nonlinear curve the our actual value. So we have corrected. For that purpose we have drawn one tangent line with this curve portion. Just wait. We have drawn a tangent line A with this our actual consolidation line, and from this line you can calculate our actual initial reading of the consolidation. Okay, so is produced back to the meet the ordinate and meeting RC, which is called the corrected zero reading, and the consolidation between R0 and RC is called initial consolidation. So R0 to RC, this value is this R0 to RC, this value is initial consolidation. From RC another line B is so drawn, that is abscissa. That is abscissa at every point is 1.5 times. So another line from RC is drawn to actually to represent this value, because we need the already I have told that 60 to 90%, 60 to 90 value, this U60 to U90, this is the actual line. This is the actual line, and this is the straight line. This is the tangent line. This difference is 1.15. Okay, same thing also we need here. B line also we have drawn. The difference is 1.15 times from the A line. Okay, the difference of A line to B line is 1.15 times. First, the lab value we are getting this solid line, then we have to draw one tangent, that A value. From this A line we can get the RC value, corrected value of R, and this difference is initial consolidation. And also you have to draw B line from RC to represent the deviation value, 1.15 time deviation. So it is so drawn that is abscissa at every point is 1.15 times that of line A. The intersection of line B with the consolidation curve gives a point P corresponding to 90% degree of consolidation. So when your B line will touch the actual consolidation line, the point will be defined by P. Okay, these touching point, this P point will be considered as the point where your sample is consolidated with 90% degree of consolidation. Actually, the purpose of this B line is to find out your U90 value. Okay, if it is your U already mentioned, that is at R0 is your U is 0, but when this B line, the 1.15 deviation line from the A line, is touching your actual curve, where it is touching your actual curve, this point is considered as your U90, 90% degree of consolidation, U value. So from this curve, the actually purpose of this graph is to find out your U90 value, because this is the actual formula to find out your coefficient of consolidation. Cv equals to Tv90 d square by T90. So Cv value is the Cv means coefficient of consolidation. Tv90, from where we can get this Tv90? Tv90 we can get from this graph, and to draw this graph we need these values, and these values are available from our laboratory test. So if I have the values from laboratory, like elapsed time test is the simple, and the dial reading at every elapsed time, what is the dial reading, and we can find out this root over t from the elapsed time, no problem, but this dial reading is needed. How much my sample is decreasing its height, decreasing its volume, decreasing its voids, we can find out from laboratory. So when I have the available the laboratory value, I can draw this draw this figure or draw this graph, and after drawing this graph, U90, when U90 value is available with me, I can calculate the coefficient of consolidation, CV value. CV value equals to Tv90 into d square by T90. This is very important value you can write, because for every calculation of every numerical problem, this equation is required, CV value is required. This is one of the important formula for calculate. I think you can apply for GATE this time. You are allowed for 2021 GATE, so you can take preparation for GATE also. This subject is very related to GATE. You can get 25 to 30% question from this subject. Okay, so study well, and I think structure, soil, these two subjects are very important, and for the time being you have available these subjects also, only this structure and soil and transportation you have. So these chapters are very important to find out for GATE and other exams also. After that, after find out this CV value, where you can see the already mentioned the where T90 equals to 30.1 minutes, that is 30, T90 is 30.1 minutes, T90 is actually 30.1 into 60 seconds. Okay, this value actually we can find out from this 30. This elapsed time is 30, and so 30 or 30.1, so 30.1 into 60 seconds. Okay, here equals to, if we square this 5.5, we can get this 30.1, T90. Actually this value is T90. TV90 is the times factor corresponding to 90% U. TV90 times factor corresponding to 90% U, that is 0.848. Table 15.1. This TV19 TV90 is a time factor corresponding to table 15.1. Table 15.1 already given in the this part. 15.1. This is the 15.2. Same like this table, we had 15.1, and from the 15.1 we can calculate the TV90 value. TV90 value is 0.848, and in your numerical problem automatically you will get this TV90 value, time factor value available in your numerical questions. D is the average drainage path for pressure increment. Okay, this D value also we can calculate by this formula, H by 2 equals to half into H1 plus HF by 2. Okay, H1 is the initial height, HF is the final height of our specimen, and finally we can calculate the CV value. This formula is important, and calculation of TV90. Then another method is there, logarithm of time fitting method. Just some question is needed to discuss. Logarithm of time fitting method. This method actually suggested by Casagrande, actually developer of your liquid limit test apparatus, Casagrande apparatus, which is actually used to find out liquid limit value, or your the division liquid limit and plastic limit. Inventor of your this Casagrande apparatus, same person who is suggested this logarithm time fitting method, which is based on characteristics of the U log 10 TV base TV plot, in which interaction of tangent at the point of inflection and asymptote of the lower portion is at the ordinate of 100% U. These characteristics is used to determine the point of 100% U on the semi-log plot of laboratory time concentration curve. And this figure you can see the theoretical curve where the plotting of the test values are shown. Actually, for logarithm time fitting method, we need the log graph, semi-log graph, and the same value we can plot, which are plotted in your square root of time fitting method. Okay. Same value which we have used for square root of time fitting method, we can use for logarithm time fitting method also. Just here the difference is you have to use a semi-log graph paper to plot your data. Okay. Also, from this table, from this graph, also we can find out which is important, our this TV90 value. Same object of the graph, plotting of this graph is same. To find out this TV90 value, when this TV90 value is available to me, I can calculate the coefficient of consolidation. And this, for this calculation of TV90 value, we need the laboratory readings. These readings are needed to plot this graph, and from this graph, for this square root of time fitting graph, or from this logarithm graph, we can calculate the TV90 value, and TV90 value is when is available, then we can calculate the coefficient of consolidation. So nothing is extra, just semi-log graph paper is used to find out the your time factor value. Actually, time factor at 90% degree of consolidation or compression. After that, some numerical is important. For one numerical you have to solve today. Just wait. Just wait. Do you have the pen and paper? Okay.
Yes, sir.
Be ready. Just you have to write one numerical. This is from actually our BC Punmiya book. First problem. Just write the problem. I'm showing you the question. Wait. Just wait. I'm showing you the question. Please write this question. Write this question. This is your assignment. Actually, you have to send me the picture. Okay. Please write this question. An undisturbed sample of clay, 24 mm thick, consolidated 50% in 20 minutes. Okay. When tested in laboratory with drainage allowed at top and bottom, the clay layer clay layer from which the sample was obtained is 4 meter thick in the field. How much time will it take to consolidate 50% with double drainage? If the clay stratum has only single drainage, calculate the time to consolidate 50%. Assume uniform distribution of consolidation pressure. Please write this question. All of you please write this question. Have you written question, Abhishek? Now, as you can see, an undisturbed sample of clay 24 thick, consolidated 50% in 20 minutes when tested in the laboratory with drainage allowed at top and bottom. When drainage is allowed at top and bottom, that is double drainage. Okay, we are allowing drainage from both the side, top and bottom. Our sample thickness is 24 and consolidate 50% in 20 minutes. This is the rate of consolidation. 50% consolidate in 20 minutes. From this timing and this value, percentage value, we can understand the behavior of the sample also, behavior of our soil also. Okay, this is one of the important. Time is important, and consolidation value or consolidation percentage also important to identify our soil. How much soil is porous, how much voids are present in the soil mass. The clay layer from which the sample was obtained is 4 meter thick in the field. This is our laboratory value, and this is our laboratory value, and this is actually the field condition from where the sample was taken. In the field, the actual soil sample is 4 meter thick. How much time will take to consolidate 50%? If in the field for 4 meter is thick, so in the field, how much time will take to consolidate 50% with double drainage? Okay, because in our laboratory we allowed to drain from both the side, that is double drainage was allowed in the lab. The thickness of the sample was 24 and the consolidated rate which was 50% in 20 minutes. So laboratory value is available for the same soil from where we have taken the sample. Now we have to calculate the actual value of the field from this reading. This is the actual question. And another question is, if the clay stratum has only single drainage, so single drainage means drainage is allowed at top or at bottom, not from both the side. Only top or only bottom side the drainage is allowed, then we can say the single drainage. And double drainage is when our surrounding is, in our laboratory test you have seen our sample is surrounded by some ring. So in lateral direction, is x direction, no drainage is possible. Only drainage is possible from top or from bottom. So at bottom side and at top side is drainage is possible, but in from another direction it is not possible to drain the water. So when single drainage, some phenomena is there. Now calculate the time of consolidate 50%. Time of drainage is maximum. Suppose double drainage, your time is needed less. But when your drainage is single drainage, your time will be high, because you allowing to drain your the porous water from the soil highly you are opening both the side, because you are allowing much more water to expel out from the sample in double drainage case. But in single drainage case you are allowing from one side only, so expelling of water from the soil sample is very low, so time is much more required from the double drainage in single drainage. And assume uniform distribution of consolidation is special. Uniform distribution means you are putting uniform load to the sample. Okay, suppose elapsed time, already I have discussed or you have seen the elapsed time. During this elapsed time, during this elapsed time, during this elapsed time where we are putting the uniform load, suppose first load is 10, then 20, then 50, then 100, 200, 400, 800, so load is uniform. That type of problem you may get, this you may get in your any examination. This is the very simple type of question normally may be asked in your examinations. Solution is simple. Solution is simple. For the same degree of consolidation, TB is the same, time factor is the same, hence T proportional to D square by CV. Also, since both the soils are the same, so time proportional to your depth D square. Okay. For the same case of double drainage, condition A, T2 by T1, this formula is needed to find out the find out the actual time, because time is important. So D2, where D2 is the drainage path in the field, 4 by 2, D1 drainage path in the laboratory specimen, 2.4 by 2. When your drainage is double, so it would be divided by 2, your thickness will be decreased. Okay, when the drainage is double, your thickness will be divided by 2. Remember, T1 time for 50% consolidation in the laboratory, that is 20 minutes. Now T2, from this formula, T2 equals to T1 D square by D1 whole square equals to 20, that is T1 20 into D2 200, because our actual height was in the field is 4. Due to double drainage, we have divided by 2, that is 2 meter or 200 centimeter, and by 1.2. The 1.2 is D1. D1 is the drainage path in the laboratory specimen. Also in the laboratory we have used double drainage, so 2.4 was our thickness of the specimen, 2.4 centimeter or 24 millimeter. So 2.4 divided by 2, that is 1.2 centimeter. Now our T2 value, T2 is our time for 50% concentration in the field, that is uh, this minutes, that much of minutes, and converted to into days, because time we can calculate in any unit, minutes, seconds, hour, days, months, year. Okay. And next question, for the case of single drainage, for single drainage just changes only D2 value. D2 value is in the field was 4 meter. Due to double drainage we have divided by 2, but for single drainage we should take the same value, the same depth of the actual in the, which is actual in the field, that is 4 meter. 4 meter equals to 400 centimeter. So T2 equals to 20. 20 is our time for 50% consolidation in the laboratory. 20 into 400 by D1. D1 is 1.2 centimeter, because in our laboratory we have taken double drainage, so this value we should take 1.2, and our T2 value is 1544 days. This is the solution of this problem. Please write this solution. You have to send me this picture in my Gmail. This is your one assignment. Based on these assignments, I will give you marks, extra marks, everywhere, in theory, in practical, wherever it's possible. एक minute. Thank you. You can leave. Thank you.